All right, welcome back from lunch. If you're still eating, that's great. We welcome you to continue. We're going to wrap up our conversations and listen to our first power talk by Jill Marver and Sally Blair, the dream team of Energy Code ACE. That's how I like to think of them, with a talk called Teamwork Makes the Schema Work.
Okay, hi everybody. I'm Jill Marver with PG&E, and I oversee what we call the Compliance Improvement Subprogram. And we've been swimming in a schema the past, I don't know how long now, Sally? 3 years. I'm here with Sally Blair of NORESCO. She's helped me on this project, so we're going to team tag this today. So first of all, why would PG&E and compliance improvement be involved in this whole thing? Well, I cannot see my slide from here. And if I move away from the microphone, you won't hear me. So, thank you very much. Okay. So when I first started in this compliance improvement subprogram role, we did a needs assessment, and this was years ago. And the very first thing people said was, well, you need to simplify the code. And I know some of you are going to chuckle because we just had that discussion in work group 1, right? And we said, you got to TurboTax it. It should be that simple. I don't have to be a tax accountant in order to do my taxes. I don't want to have to be a code expert to do my code compliance. So TurboTax it. Well, then in 2013, with that code cycle, if you'll remember, the state really put a lot of emphasis into their non-res lighting requirements. Well, that scared literally the lighting rebate program managers inside the utilities, because that was our bread and butter for our energy efficiency portfolios. And they said, you've got to figure out a way to make these lighting programs still work. So in comes Sally, and we go out and we talk with some people who are doing lighting retrofits in the state. We look at how they do things, and we started coming up with an electronic form. The birth of the PDFs that people have been using for their non-res prescriptive projects over the past few years. While we're doing that, CalBEM submits a letter to the commissioner complaining about the amount of forms they have to complete for a project and how complicated the code is. That's when we synced up with the CEC and said, well, we've been working on this lighting form to try to, simplify and automate the process. Let's give it a shot. Well, let's try doing some more forms and see how it works. So we launched what we're calling the Virtual Compliance Assistant. Went through several names, was the Mother ACE for a long time, because if you know our website, our tools they all have ACE in the name. Well, this was going to be the mother of all of them, right? But it's the Virtual Compliance Assistant. And coming January 1, 2023, with the 2022 code cycle, people will be using this Virtual Compliance Assistant or Energy Pro to complete their non-res prescriptive forms and also non-res performance.
Performance is through CDOT.
A little bit later, Energy Pro. So I think we're finally meeting what I heard in 2008, TurboTax it, Jill. It's taken a while, but we're anxious to see where this leads. And the reason that we're talking about this with all of you is that we've got a schema, and that's available to anybody who might want to try creating something like the Virtual Compliance Assistant, and how because it's basically the rule set for the code. And I'm going to hand this over to Sally to tell you a little bit more about what it looks like.
All right, I know a lot of people in this room know a lot about schemas. Some people know way more about schemas than I do. But some of you guys may not be familiar with that term. So this is what a schema looks like. It's a bunch of code, and simplistically, it essentially just lays out rules. So when a permit applicant uses an online tool or any tool to enter their project data into that tool, they can compare that project data to the rules that are in the schema, and then they will pass or fail. So it's kind of a pass or fail feature. The reason it's important is because, as Jill said, it contains the rule set. So for prescriptive and mandatory compliance forms, the requirements to comply with the energy code are built into the schema. So any tool that uses the schema will be using a consistent rule set that's been published by the Energy Commission as something that can tell you whether your project complies or doesn't comply. The other thing it does is make sure that the data set is complete. So if the user misses putting in a required field into the tool, the schema will fail that project data set because there's a missing field. So part of what we can do is gather data from all of these different tools, and the data will be consistent because it's been gathered per the schema, and we know it will be complete because it won't validate with the schema. It will fail if all the required fields aren't there. And then the last thing that this really brings is it enables the data to be passed between different tools. So people can use their tool of choice. For the 2022 code, data will be passed from the compliance certificates to the installation certificates. So we're going to partially complete install certificates with what was permitted on the NRCC. And it doesn't matter what tool is used because everybody who uses the schema, the data will be consistent. And so the tools will be able to pass the data back and forth. So last slide, because I know we're out of time, is anybody who is building a compliance tool to complete non-residential forms or non-res install certificates can have access to the schema. It's on a private GitHub repository. You can email Ben Layler or you can email Che Geyser at the Energy Commission and get access to these schemas. They're complete and they're done and they're posted on GitHub. Thank you.
Thank you.
All right, next I'd like to welcome Eric Kolderup to the stage. His presentation is titled Standard 209 and the Quest to Make a Difference.
Thank you, Lise. So this is a story, a short story, and some of you will already know a bit of this, so please bear with me. But to understand how Standard 209 came to be, it's important to understand the story of the energy modeler's lament. It's an old story. Once upon a time, there was an energy modeler. They were passionate about building performance and they worked very hard. You guys all worked very hard. Often late into the night, analyzing and optimizing. And after a long season of many projects, they took a pause to look back at their accomplishments, and what they found was that despite their efforts, in many cases, they identified an optimal window area, but the design wasn't changed. They compared the performance of HVAC system options, but the cheapest system was ultimately selected. They evaluated a dozen different glazing options for an all-glass west-facing facade. They spent late nights chasing one more lead point for a mediocre design. And they helped a suboptimal design comply with code. An important service, but not completely satisfying. And then, only a few times did they feel like they really made a difference. And so this made them sad. And they were sad because the building industry wasn't taking full advantage of the value of BEM. In their experience, a modest investment in early modeling would reap the best benefits, but it just wasn't happening. So, so what did they do? They ventured forth. They met energy modelers, and they found that that they shared this sadness, right? And they resolved to do something about it. And so, what do energy modelers do to try to get invited to the design table? Well, they write a standard. They're engineers, right? And they come up with the catchy title of Energy Simulation Aided Design for Buildings Except Low-Rise Residential Buildings. So the strategy was that, if adopted, the standard would force teams to invite them to the design table, right? So they're very socially skilled group of people. This is the way they get invited. So they gathered back in 2011, and only 7 years later, the standard was published in 2018. And so what they created was a process standard. It's not a design standard like 90.1. And so a project that complies with standard 209 would meet minimum requirements for using energy modeling during the design process. And oops, how did that happen? Oh, this is the older version. Okay, didn't get the latest version. So the general requirements, so what's in it? There are 4 general requirements that any project needs to do. You need to do a climate and site analysis, pretty simple, do some benchmarking, hold an energy charrette where you discuss goals, and then also establish energy performance goals. So these aren't like directly energy modeling related, but these are related activities that you have to do. And then there's a menu of modeling cycles. So that was the concept that was come up by the authors of the standard. And there are design phase modeling cycles. So there are 7 of them: simple box modeling, conceptual design modeling, load reduction modeling, HVAC system selection modeling, design refinement, design and integration and optimization, and energy simulation aided value engineering. So the idea is, to comply, you have to do 2 of these things. It's not like best practice, and no project does all of these things, but you need to do number 3, which is called load reduction modeling, and it needs to happen before the end of schematic design. So that was one of the main goals of the authors, is to get some modeling done at least before the end of schematic design if you wanted to comply. Of course, we know that you can do better than that, right? And there are also some additional modeling cycles for the construction and occupancy phase, but those are just optional and they aren't required for minimum compliance, right? So I just want to back up a slide. If you want to know more, one way to do it is check out the Architect's Guide to Building Performance, published by the AIA, available free online, and it actually has some pretty good descriptions of the requirements of Standard 209. So then let me get back to my last slide. You know, so like returning to our story, right? The modeler now faces a challenge, right? We've been chasing this seat at the design table, and I think most will agree that it's important that they be there, right? We want to be at the table. So the challenge is being able to deliver timely and useful information when we are invited to the table. So that's, you know, a task for all of us here at CalBEM, is to help the modeler be able to, you know, drive this car when we do actually catch it. There you go.
Thank you, Eric. All right, and then up next, I believe we have a pre-recorded power talk, which for a hot second we thought maybe the slides hadn't gotten recorded, but stick with him for a couple seconds and you'll see.
Good afternoon. My name is Drew Thompson. I work for Willdan, a third-party implementer for the California statewide new construction program, also known as California Energy Design Assistance, or CEDA program. In my presentation, The Nuances of Net-Zero, I'm going to spend the next few minutes talking about how energy design assistance remains a necessary component in the drive towards net zero building construction. I'm the program manager for the CEDA program, and I come from an extensive background in energy efficiency projects. My experience in the industrial and agricultural sectors has prepared me to lead the charge in the very progressive California energy efficiency market, and I look forward to advancing the resiliency of new buildings in all market sectors. For nearly 2 decades, Net zero has been a rallying cry for sustainable design. In 2006, solar and wind energy represented a negligible part of the grid, but in the past 15 plus years, solar and wind have become the fastest growing sources of energy. As we approach 2030, we have the opportunity to reflect on the evolution of the net zero approach and expand our thinking to include the goals of the energy supply and demand infrastructure. The challenge is the grid must always strike a balance between energy generation and consumption. Historically, the balance was maintained by adjusting power plant generation to match demand. Not long ago, energy supply and demand was relatively simple, and in 2006, the grid looked something like this. Based on our current trajectory, the grid will look more like this as we approach 2030. As wind and solar energy have become a significant part of the grid, we've continued to use fossil fuel plants to adjust and maintain the balance between energy generation and consumption. Energy storage is going to be a big part of this evolution. Batteries can take energy from wind and solar sources and allow us to use that energy when it's calm and cloudy. However, in order to get beyond 80% clean energy, we're going to need more than just storage. Load shaping provides building designs that are flexible enough to adjust the timing of energy consumption. Load shaping shifts energy use hours from high demand with low energy availability to low demand with plenty of energy availability, such as adjusting building temperatures to reduce heating and cooling loads during peak hours, raise temperatures in water heaters when energy is cheap and clean, then let the water cool down to normal temperatures when energy is at its peak, or dim lighting slightly during times of high demand. As more renewable energy is incorporated, building design teams need to be thoughtful about how to support the reliability of the grid through the balance between generation and consumption. Buildings that focus on renewable energy before efficiency may average out to zero energy, but they do so by consuming or exporting large amounts of energy at different times, putting more stress on the grid. Buildings play a more proactive role in balancing the grid with load shaping and efficiency. We can more cost-effectively achieve our decarbonization goals. This is what the CETA program seeks to do through the Energy Design Assistance for new construction projects. CETA is a utility program that provides complementary energy design assistance with customized energy modeling, simulating building energy use. The program incentivizes customers and design teams to adopt high-performance energy efficiency measures and drive towards electrification while promoting grid health through integrated demand-side management, or IDSM, best practices. There are many avenues for participation in the CETA program. The flexibility of the program incentive structure allows us to target energy modeling and design teams by encouraging their involvement through a design team incentive. The goal of this component of the program is to provide design teams the ability to work energy efficiency incentives into their projects while leveraging Willdan's experience pushing energy modeling packages through the California Public Utility Commission, or CPUC, approval process. This opens the door for increased design team participation, leading to more energy design assistance, which will blend net zero design into a well-balanced grid. Thank you for listening, and I hope you enjoyed my take on the nuances of net zero. Please reach out if you have any questions. You can find me on the ChimeGo app at the link seen below, or you can reach me at drew.thompson@willdan.com. Thanks, and have a great day.